All right, so today we're going to pull back the curtain on AI. We're going to break down the 3 fundamental ways a machine actually learns. And no, it's not magic, it's just a set of really powerful methods. So let's dive right in.
Okay, so let's just start with the biggest question of all, right? When we say a machine learns, what are we really talking about? I mean, it doesn't have a brain like we do, no memories in the human sense. So how in the world does it go from being, a total blank slate to being able to spot your cat in a photo or dominate a game like chess?
Well, the secret, it really comes down to one word: data. That's it. An AI learns by just churning through massive, massive amounts of information. But, and this is the key part, how it processes that data is what makes all the difference. We're about to look at the 3 main ways we can teach an AI, and you'll see that each one is built for a totally different kind of challenge.
Okay, so our first method, this one's probably the most common, and it's pretty straightforward. It's all about learning from data that already has the answers included. Yeah, think of it like having the perfect cheat sheet or study guide from the very beginning.
Right, so this method is called supervised learning. And honestly, that flashcard analogy you see here, it's spot on. Just imagine you're feeding an AI a giant, endless stack of digital flashcards. On one side of the card, there's a picture. On the other, the correct label. The machine just goes through them millions and millions of times until it starts to connect the dots and see the patterns. Kind of like how we cram for a test, right?
And this is a perfect way to see it in action, the classic cat versus dog problem. So first step, you just dump in a ton of data, thousands, millions of pictures that a person has already labeled cat or dog. Then for step 2, the model gets to work. It starts analyzing all the cat pictures, looking for common features, pointy ears, whiskers, that sort of thing. It does the same for the dogs. It's basically creating its own set of rules. And then the magic happens in step 3. You show it a brand new picture it's never seen before, with no label, and boom! It can tell you with pretty amazing accuracy if it's a cat or a dog, all based on those patterns it learned.
And look, this is way more than just sorting pictures of pets. You actually use supervised learning probably every single day without even thinking about it. That spam filter in your email? Yep. That's a model that was trained on millions of emails that were labeled spam or not spam. Or how about your bank's fraud detection? Same thing. It learned from a huge list of transactions labeled fraud or legit. It is an incredibly powerful tool for sorting and classifying things. So yeah, supervised learning works great if you have all that nice, clean, labeled data to start with. But what happens when you don't? What if all you have is just a giant, messy pile of information with absolutely no labels? What do you do then?
Well, that brings us to method number 2. And this one is designed for chaos. This is where the machine gets 0 answers up front. Its only job is to dive into the mess and find the hidden patterns all by itself.
So this is called unsupervised learning. The flashcards are gone, the answer key has been thrown out. All you do is give the AI a massive, unlabeled pile of data and say, go figure it out, find the patterns. The analogy here of sorting fruit is perfect. It's like someone hands you a huge bag of mixed fruit and you start sorting it into piles based on what looks similar, by color, by shape, by size, even if you've never been told what an apple or a banana is.
The model basically turns into a detective, right? It just sifts through all this raw data looking for things that naturally clump together. And this is so important because, let's be real, most of the data out there in the world is unlabeled. This approach lets us find meaning in these just oceans of information that no human could ever hope to sort through. It's all about finding the hidden structure that's already there.
And here's a great example of where this is used all the time. Think about a big retail company. They could use unsupervised learning on all their sales data. The model might sift through it and discover, hey, there's a group of people who only shop on weekends. And over here, there's another group that only buys stuff when it's on sale. The company never told it to find those groups. The machine just found them on its own. And just like that, you have super valuable customer segments you can market to.
Okay, so we've covered learning with the teacher, that's supervised, and learning by just finding patterns on your own, unsupervised. Our third and final way is, well, it's completely different from the other 2. This one is all about learning from trial and error. It's learning by doing.
And this is called reinforcement learning. It's really all about a simple feedback loop. You have an AI, which we call an agent, and you put it in some kind of environment. It learns by just trying stuff. It takes an action to try and get a reward. If it does something you want it to do, it gets a little virtual treat. If it messes up, well, it learns from that too. And over time, through tons of trial and error, it starts to figure out the best strategy to get the most rewards.
The most famous example of this, for sure, is in game-playing AIs, like DeepMind's AlphaGo. Think about it. In a super complex game like Go, the agent makes a move. If that move helps it get closer to winning, it gets a reward. If it's a bad move that hurts its chances, it gets a penalty. So what does it do? It plays millions and millions of games against itself, constantly tweaking its strategy. Over time, it builds this incredible intuition and starts discovering moves and strategies that no human player had ever even thought of. All from that simple loop of trial, error, and feedback.
So there you have it. Supervised, unsupervised, and reinforcement learning. Those are really the three main pillars of how machines learn. But it's really important to know that they're not always used separately. For the really, really hard problems, researchers will often combine them or scale them up in massive ways. And that's when you start to hear buzzwords like deep learning and neural networks. But that's a whole other story for another day.
Which kind of leaves us with this one final thought, right? We now have a pretty good handle on the how we actually teach a machine. So the much bigger and maybe more important question for all of us is, what do we choose to teach them next? Thanks for watching.